How lightning can strike the same place twice, and even 3 times, challenges one of the most persistent weather myths on Earth. The popular belief that lightning never strikes the same place twice is not only wrong but contradicted by scientific data. In reality, some locations are struck dozens, even hundreds of times, depending on atmospheric conditions, terrain, and structural features. Lightning forms when electrical imbalances build between storm clouds and the ground, creating sudden surges of electrical discharge. This discharge, called a lightning bolt, seeks the path of least resistance to balance the electrical charge difference. Tall structures, isolated objects, and conductive materials offer lower resistance, making them frequent lightning targets during storms. Lightning rods on skyscrapers, antennas, and tall towers exist precisely because lightning frequently returns to these elevated objects. The Empire State Building in New York City is struck by lightning an average of 20 to 25 times per year. Some studies show that particularly conductive areas, such as mountain peaks or metal towers, can be struck dozens of times during a single storm. Lightning follows ionized channels formed during previous strikes, meaning a bolt may reuse the same path multiple times. When a lightning bolt strikes, it superheats the air along its path, creating a channel of ionized air called a plasma channel. This channel remains electrically favorable for a short period, allowing follow-up strikes to travel the same path seconds later. Some multiple strike events involve a series of rapid return strokes, where 2 or more bolts follow within milliseconds. Scientists using high-speed cameras have captured lightning bolts striking the same point up to 7 times in a single flash sequence. These return strokes explain why some lightning strikes appear to flicker. The eye is seeing multiple strikes along the same path. Certain geographical features, such as high ridges, exposed plateaus, and tall isolated trees, are natural lightning magnets. Mountain peaks, where storms frequently form, often serve as repeat lightning strike points due to elevation and reduced air resistance. In areas where thunderstorms frequently form, objects like transmission towers and radio antennas attract multiple strikes over their lifetimes. Lightning is also attracted to materials with high conductivity, such as metal, water, and moist soil, further increasing repeat strike potential. Coastal areas where land meets moist sea air see increased thunderstorm frequency, making lighthouses and coastal towers frequent lightning targets. Urban areas with clusters of tall buildings experience enhanced lightning activity due to the collective height of skyscrapers. Lightning doesn't remember where it struck before, it simply follows the same physical and atmospheric factors that existed before. Structures that modify the electric field around them, such as tall spires or metallic domes, naturally attract lightning more than surroundings. Repeat lightning strikes also occur in locations with strong updrafts, where storms repeatedly form along the same geographic features. In areas like Florida's Lightning Alley, warm ocean air, flat land, and frequent sea breezes create ideal repeat strike conditions. Some weather monitoring stations, positioned on exposed peaks or ridges, have been struck hundreds of times since their installation. Trees struck by lightning can be hit multiple times if they remain taller than surrounding vegetation and maintain moisture inside. Even the ground itself can be struck more than once in the same location if soil conductivity and terrain favor repeated discharges. During volcanic eruptions, volcanic plumes generate static charge, creating volcanic lightning that can repeatedly strike the same areas near the crater. Tall radio towers positioned near storm-prone regions are sometimes struck multiple times within the same storm system. The tallest structure in an area doesn't just increase the chance of a first strike but also of repeated strikes in following storms. Airports with tall control towers and expansive open areas experience repeat lightning strikes more often than heavily forested zones. Narrow canyons, where electrical fields concentrate along ridge lines, can funnel lightning strikes into the same zones repeatedly. Scientists studying lightning at research facilities use towers designed specifically to attract repeated lightning strikes for data collection. The recurring strikes at these facilities demonstrate how the same physical factors continuously influence strike location. Even when lightning strikes open ground, the electrical properties of the soil may make that spot more likely to attract future strikes. Sandy, dry soils are poor conductors, while wet, mineral-rich soils offer lower resistance, increasing repeat strike likelihood. Tall metal frame structures, such as power line towers, act as ideal lightning rods, drawing repeated strikes during active storms. Aircraft flying near thunderstorms sometimes experience repeated lightning strikes when passing through electrically charged regions of the sky. Lightning protection systems on buildings and airplanes are specifically designed to manage repeated strikes without structural damage. Some research indicates that certain regions, such as the Lake Maracaibo region of Venezuela, experience extreme repeat lightning activity. Lake Maracaibo's unique geography, moisture levels, and atmospheric instability produce near-daily thunderstorms, generating repeated lightning over the lake. The phenomenon of repeated lightning strikes is common enough that NASA and meteorological agencies design sensors specifically to track multi-strike events. High-speed lightning mapping arrays detect when a bolt branches out, striking multiple points or returning to the same point multiple times. While rare in any single location, tall isolated trees have been documented to endure multiple lightning strikes over decades. Trees scarred by lightning develop open channels where moisture and nutrients flow, creating natural conductors for future strikes. In areas where wildfire risk is high, repeat lightning strikes on dry trees or shrubs often trigger devastating fires. Certain animals, including some birds and livestock, have been struck by lightning more than once, often due to standing in exposed areas. Lightning safety experts emphasize that just because an area has been struck doesn't make it safer, it may actually be more vulnerable. The science of repeat lightning strikes is critical for designing safe buildings, power grids, and outdoor infrastructure in storm-prone areas. Understanding why lightning returns to certain places helps improve early warning systems and reduce lightning-related damage and casualties. While lightning striking twice is unusual for any single small object, it's a regular occurrence for larger structures and landscapes. The idea that lightning never strikes the same place twice is simply wrong. The science proves that it can and does, often spectacularly. As climate change increases atmospheric instability and storm frequency, understanding repeat lightning strikes will become even more important for protecting lives and infrastructure.